Let's begin section 5.2. Section 5.2, what we're looking at is a specific type of discrete probability distribution. What we want to do is first talk about what a binomial experiment is, and then we'll go over how to work with it, how to compute things, and how to answer questions. So first of all, a binomial experiment has four key criteria. And if an experiment satisfies these, it's a binomial, and if it's missing one of these, then it's not binomial. And there are other discrete probability distributions out there, but if we don't satisfy all four of these, it's not a binomial, and this is the only one that we're going to really focus on in this class, at least for the discrete. So here are the four criteria. Number one, there needs to be a fixed number of trials. That means that before I start the experiment, I know how many repetitions of whatever random event I'm going to be doing. For example, if we're flipping a coin, and I say I'm going to flip a coin 10 times and count how many heads there are, then that's a fixed number of trials. If I say I'm going to flip a coin until I see heads show up 5 times, then I don't know ahead of time how many times I'm going to be flipping, so that's not a fixed number of trials. Second criteria is that the trials are independent. Okay, so we talked about independence in the probability chapter. And remember that it means that what happens with one event doesn't influence the probabilities of the other ones. The third criteria is that there are 2 possible outcomes for each experiment. Okay. Now we're going to call these success and failure, but that doesn't imply anything about being good or bad. It just means that there's 2 possible outcomes, and we just need to label them. So if I'm flipping a coin, I could call them heads and tails instead. Okay. Success and failure are just a default way to refer to the 2 outcomes. And the final criteria is that the probability of success doesn't change from trial to trial. So I have some probability P equals, and that's going to be the same throughout the experiment for each trial. Okay, so some examples of things that are binomial experiments. Okay, toss a coin 10 times, find the probability of getting 2 heads. Okay, so we have a fixed number of trials, 10. The trials are independent because the coin doesn't know what happened before or after. Okay. There are only 2 possible outcomes, heads or tails. And the probability of success, probability of getting heads, is 50%. It's the same for every coin flip. Right. Question 20 people in class and look for the probability of more than half of them being women. Okay. So again, in this case, the trials would be asking the question. So when we say we have a fixed number of trials, in this case we're asking a question to 20 people. So there the number of trials would be 20. Okay. So the trials being independent we'll dive into in a little bit more deeply later. But we can say that if you ask somebody a question and you get an answer, that doesn't influence how other people feel. That's kind of one way of thinking about it. It's not quite that simple, and we'll delve into that in a little bit deeper in a little bit. Okay. The third criteria, there's 2 possible outcomes, and what we're doing is looking for the probability that more than half are women. So the person is either a woman or not, and so that's 2 possible outcomes. And then the probability of success doesn't change from trial to trial. Okay. And the last example here, we shoot an arrow, well, one at a time, right? 5 arrows at a target, so the fixed number of trials, n is 5. We have 2 possible outcomes, we either hit or we miss. The trials are independent. It's maybe a little bit of assumption, right? We're not really getting any better or worse as time goes on. And then the probability of success hitting the target is the same for each shot. Okay, so that's looking at whether or not we have a binomial. And so these 4 criteria are what you would want to check. So that's definitely something that you want to make sure that you have written down that you can reference when you need to check and see, is something a binomial? Or if you're looking at what type of distribution am I looking at? If I have a random variable, what kind of random variable is it? One option is that it's a binomial, so you check these 4 criteria.